Hello. Good morning. Good morning. I think that you are sleeping, but no, because you have a very nice presentation before, and I take advantage of that because I will don't take about these things. Well, this is okay. What I want to talk is about climate smart conservation strategies and using a project, which is a case, to see how this experience could be go to this strategy. Then, first of all, I don't talk about climate change information, and also this is no result of research because it's about how can apply a methods for conservation and conservation in the wide concept under climate change. Because we know that climate change most of the time is not included in conservation or restoration or planning before 5 years ago. Now it's important to include that. This is a method or approach to try to understand how climate change could be included into the methodology to work and engage with the stakeholders. And this, what about this presentation is, first, I will present the Action Ramsar project. Second, I will talk about little bit about conservation standard, which is the approach. And at the end, I will talking about implementation of climate smart strategies into this project. But first, the project was last year, between 23 and 24 years. We have into the project a challenge that we call operational channels that we need to have into the project, integrate the situation at the state level in agreements, international or national agreements. Also take something about hydrology, of course, biodiversity, climate change, and ecological transition, and take about biodiversity of marine environment. For that, we're thinking in how can resolve this challenge. One is use Ramsar sites, and because it's international convention, and also include the possibility to work in all the areas that the wetlands. And we take the examples of REWET. Then REWET was a nice project to see how can implement this methodology for that. And then in hydrology, we try to understand the water dynamics for climate change, biodiversity, of course, is our expertise. And for marine environments, we use then Ramsar site in this place. The project was also another challenge. Is how can integrate science that we see previously, a very nice example of what is science in wetlands, and managing. How can this science come to the people to help make management? Then try to connect this. And the objective of the project and phases was try to generate proposal of adaptation, conservation, management, based on robust scientist information derived from hydrology, biodiversity, climate change, and ecosystem service in this Ramsar site and integrate with a participatory process involving the stakeholders and managers. And this was the place, three Ramsar site, Doñana, tomorrow we will go to Doñana, Mar Menor, and the Albufera of Valencia. And also another 3 point that Don made the workshop with the stakeholders. And the objective of the project was in 3 phases. One is take information about future climate and hydrology, and with this information go to the stakeholders in a first workshop to obtain a state of the conservation of the Ramsar site, plus the information and the vision of the management and the stakeholder of what is important, what is the biodiversity more important to conserve, to preserve in this Ramsar site. With this information, we select a lot of targets and go to modeling and the biodiversity and hydrological and climate change scenarios to see how will be the impact of the climate change on this kind of diversity that is the target. And at the end, we go with this information again with the stakeholders to to give the information and generate strategies of associated mainly with climate change, because we have already for these areas many management activities about that, but not included climate change. Then this is one of the more important in this dynamics. This is the project, and it's try to integrate for one side the science with climate change, biodiversity, hydrology, biodiversity studying by modeling, species, sickness, impact analysis about the ecosystem processes, about climate change scenarios and variables, derived variables, and hydrology. Integrate with management, it is a conservation, ecosystem services, adaptation, threat reduction, restoration. And the focus of the approach will be, or was, the conservation standards. And then the main project's results was have primary data, and this data is coming from the local people and understand the climate change and give a deeper understanding of the climate impact in the site, have a rigorous scientifically local details, base an analysis on the impact of future in the hydrology of biodiversity, and understand this is a severe and should be systematically used in managing to adapt to climate change. And conservation integrate processes like species distribution under climate change scenarios, assessing the future increase of the risk like wildfires, and using method in our institute. The second, please. This? I have 3 presentations because when I read, I was 1 hour for that. Then I have many times, less time, then I have to reduce. Is this? Yeah, thank you. Okay, Now I will talk in a little bit, because I have around 100 slides about that, but I have to reduce. What is open? The conservation standard is an approach, international approach. And this presentation is not mine, it's from the consortium of the conservation standards. And what is the approach is the open standard for the practice of conservation. And it's open because everybody can use, everybody can change the way and adapt the approach in your research or in your adaptation or project of conservation, and include planning, implementation, monitoring, and learning for projects and progress. The base of this approach have the two considerations that before explained: science for one side, and the other, the management. How to integrate then is based on the evidence that coming from the science, and then also is managing and adaptive management. And it's based on the approach because the project is scope and targets, using target variability, but little bit talk about Alessandro and yeah, because talking about how species have a viability, how know if the wetland is good or not. That is important, and this is science. And very other evidence using the science. And for the other side, we have the possibility to use an adaptive management, which considers the possibility to evaluate and have a process of monitoring to evaluate if the project is coming well or not. And we are thinking if the thing, we are doing the right things, and also if these right things are doing well, and also it's not enough, I have to achieve an impact of this. Then all this is in this adaptive, and it's coming from many years ago, about more than 20 years ago, starting this model, including these different cycles, and until this, which include access, plan, implement, analyze and adapt, and share. And now is calling conservation standards. And the method is similar to science, no? When identify problem and hypothesis, design a plan, design the experiment, implement plan, execute the experiment, you get results from the project, you get the data, you analyze the result, the data, and you can revisit the hypothesis, and in the project you can adapt on change, make change. This is, in general, the open standard for the practice of conservation. Next, or if you want, 80 more. Yeah? Okay, now this is starting. Climate smart conservation, using conservation standard to address climate adaptation using Ramsar action, like an example. We use for the project only the two first phases, access and plan. Access about the scenario, the situation model, the climate threat, and revision of the targets. And plan identify climate smart strategies and include climate impacts in theory of change. What about climate change? This is a little bit more. When we are working with people, most of the people depends on where we're working, of course. Europe is very difficult, very easy, I'm sorry, because many people have more knowledge about climate. Yeah, and most of you here are young people, and you know, if 5 years ago, 5 years in forward, you will be in Nigeria or in Indonesia or in what country of Latin America, whatever. And the people could be local people from indigenous ethnias, whatever. Then we have to adaptate the information of climate change in a very well line, no? And depends what is the level of the people in terms to the information about that. Then the climate change context is challenging to fit with other threats. Then normally we don't include the threats, the climate change like a threat. Now it's obligatory, also. Teams need basic understanding the climate change. It's have to be integrated from the beginning of the project. The impact have to be deconstruct, even not talking about, okay, the temperature will be increased 2 degrees. No, it's just try to go in deep. It's a temperature, it's the average, it's the months, it's the maximum, it's the minimum. Yeah, use scenarios to explore the uncertainty, detailed guidance about availability of the information. We can use the information we don't need, or at the last, we have to use more scenarios as possible. And the response of the human, we have to take it into consideration, understand the potential effect on humans, try to predict human reaction, because many people, you don't believe it. There is a lot of people that don't believe in climate change. That is a consideration very important. And sometimes is avoid the maladaptation, which could be a problem when a project is started. I have time? Oh, yes. No more, not too much. People have hungry. Climate projection, many climate models. There is more, and in the last, not in the last, in the previous report 5 of the IPCC, I think it was more than 40 climate change climate models. Then it's a lot of information. It is important to recognize the uncertainty, look for agreement of lack of it, and planning scenarios to help the people to consider what is the impact of the climate change. The scenarios planning coming from see what is the gas emissions, model accuracy, trend direction and magnitude of the change, randomness, natural response, and human response. This is a lot of consideration done in uncertainty. And then responders to this focus on better understand the problems, wait for more certainty, proceed as is not certainty, but the better is work with this certainty. And scenario planning, this is very important with the people. Decision support tool, used extensively in military business for high certainty, help imagine a very different future, consistent stories, both science and art. Why planning in scenarios? Because explore a range of possibilities of future, different, and understand the potential impact in different scenarios, and eventually develop solutions in these kind of scenarios. There is many scenarios. Start with the basic investigation, understand climate trends, and we can go from just one scenario, two scenarios. Now we are working exactly with 4 scenarios or 5. Yeah? And how to define scenarios? We're using multiple models, different time horizons, yeah, and and multiple gas emissions scenarios, and combine all the above, yeah, and can other dimension of political, economical. This is the actual scenarios. Here, okay. No, there are different scenarios. We are now, this is the last report of the IPCC. We have five scenarios. We're working more or less with the last 4 scenarios and different periods. And this is just a picture of, for Doñana, when you have 10 different climate models for one variables in one period, and this is an uncertainty, then it's important to have this kind of difference and work with this. And this is multiplied by the numbers of periods. You can imagine how many information you can collect. And where is this information? You can examine multiple models in the bibliographies, look for a research, here is Emma, Jaime, and use a tool. This is a tools from Andalusia. We are here. Yes. Just to see this is an information created by the FIC, and you see for Andalusian different periods of time, different scenarios, and you can look for different variables. Next, just to see that there's information. And when yeah, and when working with the scenarios, with people, we have to low to the knowledge of the people. We can working with us in the science knowledge, or we can work to this in a simple way to see, okay, if we have extreme gradient of temperature with less precipitation, we have a hotter and drier, and try to explain a little bit more these possible scenarios, but going in deep what is more. In Ramsar, in the project, we use this information from climate modeling, to see how the temperature or the index of dryer in Doñana is well. This information, and we can see for different scenarios and for different periods of time, how can increase or decrease or change in the future. This information is presented to the people, presented to the stakeholders. Even this is a more hydrological modeling about Doñana, and we see in different scenarios how will be the water in the soil. And this, with this information, we go to the people and try to make an assessment of the vulnerability of the targets. And people can try this. I try to understand how climate change could be not directly, but indirectly change the scenarios. One of the things that is important with people is climate change is not tangible, ¿cómo se dice? Tangible things we cannot take, like contamination that you can also see, or you can see the forest advance with the trees. Then include the climate change into this position with the people, give us the opportunity to see how the specific climate variables could be increased at treat, at normal treats. And with this information, we see less precipitation into the climate, increase average temperature, more frequency, and try to see what is the impact about the ecosystem, and also how can this impact on the people, and which be the human reaction to these things. This is try to understand that and put this information into the scenarios. We have only two axes, but we can say on axis of evapotranspiration or temperature maximums and minimums, the temperature of the dry months of the different variables. Yeah. And with this information in the project, we working with the stakeholders. This is for the Albufera. See what is the targets identified by the people, and then how the climate change could be affect this, and make an analysis and extract what is the target and how can this target impact by the climate change. This is the next part of the project. We take these targets and try for most of them analyze the impact of future climate and hydrology and derived variables on ecosystem process, or modeling the suitable climate of phytoclimate for species, for plant species, or modeling the disease as pathogenous for species, and also modeling the risk of fire. And this is a picture of Doñana for Cork Oak and different scenarios and how can change. This information go to the second second workshop with the people, with the stakeholders, and show how can a species could be disappear in a climate scenario, or remain, or which species could be better. This is part of what is our climate smart strategies. Then also for climate weather, for fire weather index, how it change and how will be increased for this is for Doñana. And go to the situation model. This is how we work. In the picture, you see people working with the stickers, and then this is a situation model, step with the conservation target, looking for the trees, the direct tree, indirect tree, opportunities. This is part of how can work with the people in the workshop, and recognize, that's important, the climate change included into the this model situation, and join with ecosystem services, and how these ecosystem services contribute to the well-being livelihoods. This is another example for coral reef ecosystem, and you see how we can talking about the impact of climate change on acid acidification. This is what I have. No. Sorry. Revolve the scope. At the end, this is an introduction, no? The scope of the project. I stop here. When we are made this analysis with the people, we go and information, scientific information about climate, the impact, the analysis, and you put this information on the table and say, okay, we can change something. We can really change or make a conservation project has maybe thinking. Probably one of the problems is that suppose that I am working in a protected area, like a national park, and I make the information that for the future, the main species go out of the national park. Then what is the solution? Maybe the solution is a political situation with extend the national park, or just simple, I cannot do that. Just, it's not possible. The other is the conservation targets. Probably one of the species in a specific, in a place, will be not suitable in this place for temperature or for other variables. Suppose that we have a species that during winter need frozen in the soil, like tulipan. And what happens if the temperature at the future will disappear, the minimum temperature, and it's not frozen? What happened with this species? Then we reevaluate with the people what can do and what cannot do. Yeah? And also about key attributes. And after that, we try to select the people don't need to know about classification. This is for us. But the strategies could be related with reducing the threat. Yeah? With these more or less policies about something, or are associated to viability enhancement, which is clear most of the restoration process could be in this type of strategies, or adaptation to create artificial or new or understand climate refugees for ecosystem and species. Then this is what we call climate smart strategy that try to the similar way that in the conservation process normally, but thinking in the impact of climate change with all this information derived from science. And after that, we create with the people a smart result change that give the possibility to thinking in the climate change and go to try to, let's say, include stress reduction or increase the viability of the targets. Different strategies that can be good and reduction. For that, we use, of course, seasonal calendar, and there is a lot of information like this guy is about ecosystem in climate change. And what we did in the last workshop was more or less identify the best strategies for different targets. The strategies are yellow. Also try to understand the whole vision, and also understand this, how can climate change at the end could be affect human well-being, like tourism, good relation, or entrance for that. Could be have a long, big picture of the whole process and working with each one. Then climate smart have in reducing vulnerability, protecting climate refugees, improving the health of the target. Most of them is restoration. Adaptation is creating artificial condition, selecting ecological equivalent species or genetic varieties that have to replace the species that will be disappear, and prevention human maladaptation. In the work with these people, we identify just in general way 94 different possibilities to see how can change or how can adaptate to the climate change. And interesting is at the end, the government, the management is very interesting in how can use this information and show us the problem and how can we resolve this problem, in this case, especially with the repopulation activities of Alcornoque in the Doñana. This was a petition of the people from managing people. And also consider the number of persons that participate in this project, and the possibility to replicate. And then the information is very good in terms of how people understand climate and the necessity to include climate change into the project. And thinking in what is a climate smart strategy for biodiversity conservation. Thank you.